cylinder is like a prism whose bases are circles. Here are two examples of different kinds of cylinders. The one on the left is called a right cylinder, and the one on the right is called an oblique cylinder. We are really going to be dealing with right cylinders for most of the conversation, although an oblique cylinder has a radius and a height. A right cylinder also has a radius and the height, which is the altitude between the two bases. Given those two bits of information, we can find the lateral area, which is the area of the sides. If I was to take this cylinder and unwrap it, how would it look? It would look like a rectangle. We would just basically cut off the top and bottom, the bases. We would unwrap the sides. So the height of the rectangle would be the same as the height of the cylinder. The width of the rectangle would be all the way around the top here. All the way around the top of a circle is the circumference, which is 2 pi r. So the lateral area of a right cylinder is basically 2 pi r times h. Remember, the other day we talked about prisms. The lateral area of a prism is also the perimeter of the base times its height. So it's the same concepts, just now with a cylinder. Perimeter of base times the height. The total surface area of a cylinder includes the top and bottom, so we would take the lateral area, which is 2 pi rh, which we just talked about, and we would add that to the area of the two bases. Well, the two bases of a circle are, the same circle would be 2 times pi r squared. So that's the general surface area formula of a cylinder. The volume of a cylinder, recall that it would be like taking liquid and pouring it into the bottom of the cylinder. So first you'd cover the area of the base, and then it would go up till you get to the height of that cylinder. So it's the area of the base, pi r squared, times h. And again, this is very similar to the prism formulas, which first you get the area of the base, and then you multiply it by the height to get the volume of a prism. Okay, let's try to apply these new two concepts for some word problems. A cylinder has a base diameter of 10 and a height of 4. So 10 would be sort of wide, which, by the way, if the whole diameter is 10, that means the radius would be 5. And the height of the cylinder is 4 centimeters. So the surface area is the total surface area of the whole thing. So maybe we'll do, let's do the lateral area first, which is the area around the side. The lateral area is the perimeter. I don't know what this thing is doing. It's a mind of its own. Is the perimeter, which is the circumference of the base, which is 2 times 5 times pi. So that's 10. Pi is the circumference, and you multiply that times the height, which is 4. So this is going to be the lateral area part, and we add that to the area of the bases, the two bases. Two bases are 2 times pi r squared. 25 is 25 is 5 squared. So if I combine like terms, multiplying, I get 40 pi plus 50 pi for a grand total of 90 pi. And that would be, what would the units be on this one? It would be centimeters cubed. So that's the area, that's the answer to example 1. Example 2, a cylinder with height 4 and radius 6 has the same volume as a second cylinder whose height is 18. Find the radius of the second cylinder. So again, we might want to draw them. The radius is 6, and the height is 4. The second cylinder has a height of 18. Oh, that's a good one. And we have to find R is the unknown. R. Same volume. So can we find the volume of this first cylinder? The volume is the area of the base, which would be 36 pi times 4. And that would be the volume. And that would come out to be 500. Let me just double check this. 144. Pi. So we know that has to equal the volume of this other cylinder. So we know 144 pi has to equal 18, which is the height, times pi r squared. So if we divide through by 18 pi on both sides, we'll get 8 equals r squared. So the radius is square root of 8, which is 2 root 2, if you want to simplify that. Okay, so moving on to the second page. A cylinder has height of 8 and a total area of 4 pi inches squared. Write an equation and solve for r. This is a complicated problem, but we're not going to be afraid of it, and I will help set this up, and then you can solve the rest of it. So it has a height of 8 and a total area of 40 pi squared. So the total area formula is twice pi r squared, which is the, so here's the radius, which is unknown, which is the two bases, and we have to add it to the lateral area, which is the circumference, which is 2 pi r, times the height, which is 8. And that has to equal 40 pi inches squared. So let's see if we can tighten up the second term by multiplying 8 times 2, which is 16. Notice we can divide everything through by pi and be left with this. So I'm going to stop you here and see if you can solve this quadratic equation. So finish this for class before you come into class tomorrow. The next problem, a pipe has an inner radius of 5 and an additional 1 centimeter thickness. So the inner radius is 5 and the whole, all the way out, must be 6. It's 90 centimeters long. Find the volume of the water it can hold on the inside. I'd like you to try this using the volume formulas. Finish this. And the volume of the metal used to make the pipe. I want you to try this on your own. So let's just think about the volume of the metal used to make the pipe. So that would be this, what you'd want to know is the volume of this piece here. So we might have to subtract off a couple volumes. We'd have to subtract off the whole pipe minus the blank on the inside, and we would come up with our answers. So we'll go over that tomorrow in class. Make sure you do all the starred pieces, and that's all you have to do for this evening. See you tomorrow, next class.